Welcome back to Nature and Code. We're in chapter 3, and in the last video, we developed this simulation here of genetic drift in JavaScript. And we ended the video by saying we would like to understand much more about this process, but that we would need a better way to look at the outcome of these simulations. So rather than printing the allele frequencies every generation into the console, let's leverage the power of JavaScript and the fact that it runs in the browser, and create some nice visualizations of it running right in the browser. So this video will introduce some new things, because this will be the first video where we'll actually implement visualizations. And we'll do this with a framework, with a JavaScript library called D3. So if you Google D3, you'll find this d3js.org website. And here it says D3 is a JavaScript library for manipulating documents based on data. So let's click on this link. And so here you will find hundreds of enormously fascinating examples of D3 in action. And feel free to click through and just look at some of these stunning examples. However, the fact that these examples are so stunning is also a little bit reflected in the fact that D3 is actually not a trivial thing to learn. And it's a very powerful library, but also with that power comes a level of complexity that shouldn't be underestimated. Now, if you're interested, I strongly encourage you to browse this website and to check out tutorials or to consult D3 specific books. However, what we're going to do in this class, we're just going to use it as a tool. So basically, all I want you to do is, one, I want you to load the library in your documents, which I explain in a second how this works. And then I'm going to hand you some code, some plotting code that I developed specifically for this class that I'm just going to ask you to copy and paste into your document so that we can use the power of D3. But we're actually not really going to bother about understanding what this code does. And that's just because it will be beyond the scope of this class. Again, if you're curious and you want to learn more, I strongly encourage you to do that. Another way maybe to do this would be to first finish this class and get a solid grasp on JavaScript, and then delve into D3. But it's really up to you. So two things that we need to do, actually three. So first, we need to load the library. And we can do this by using this script tag here. So what this does is, rather than having actual content of JavaScript right here in the script, it basically has this source attribute which points to a document on this page, so somewhere on the web. And this is an indication for your browser to load this document. So go ahead and copy this line here, bring it over to your document, and here up in the head, just add this line as another script tag. So what this does is it loads this document into your document. And if you actually would copy and paste this, so this is where the document is loaded. If you look at this, this is the JavaScript code that you're loading. So don't worry, you don't need to understand this. This is in fact the compressed version. That's why these variables are called S and H and R and N and F and so on. There's also a non-compressed version, but this is the smaller version in terms of file size. So that's the first thing you need to do here. Now the second thing that you need to do is you'll need to copy and paste some code that I wrote. And we're going to do this in a second. However, I want you to do one thing first. I want you to take this script tag here and the code that we developed and copy it, or cut it if you will. Either way, but make sure you have a copy of it. And move it out of the head into the body here. Okay. So we said previously that for the examples that we developed so far, it doesn't matter where your script tag is located. And that was true because we were simply doing some simple calculations and we were outputting the results into the console. However, now we're going to use the data that results from the simulations, and we're going to develop visualizations that we're going to render in the browser. And that is why it needs to be in the body, because the body is the element that renders content in the browser. And also D3, the D3 library depends on this body tag, uses this body tag. All right, so that's the second step. Now the third step is to actually find the code that I developed. So you can either copy it from the book if you have it, or alternatively, go to natureencode.com, the website of the book, and you'll find here the example that we're going to develop. It's called Genetic Drift Visualized. And if you click on this, you'll see the simulation that we're going to visualize. Furthermore, you see the code that we're going to develop, and as you can see, we have already developed much of this code. And down here it says, note, the draw line chart function is built with D3 and can be found here. So click on here, and here is that function. Okay, this is a function that I developed, and it's used extensively on the website and the book and the videos. So go ahead and copy this whole function here, the whole thing up to this very last closing curly bracket. Okay, so copy this, go over to your code, and now paste this here in the body script. I would paste it here at the top. It doesn't matter where in the body script, but I'm just going to go ahead and paste it here. And so that would be fine. I'm just going to indent it a little bit, just because it's going to be a little nicer. But in any case, that would already work. Indentation, again, is not necessary. It just makes the code look a little nicer. All right, so this is where this function ends, okay? And everything down here, everything, I gotta make sure I don't delete this. Everything down here is the code that we developed previously. All right, so now would this work? Well, it wouldn't quite work yet because we still have the old here print into the console line. So we have everything set up here. I mean, we've loaded D3 here. We have our function draw line chart that is ready to be used. And we have our simulation of drift here that works. However, these two things are not connected yet. So we need to tell this simulation here, hey, don't print the results into the console. Actually create this nice visualization. So I'm going to delete this line here, console log, because we don't need that anymore. And because of that, I'm also going to delete the round number function because we don't need that anymore either. Okay, but what we do need is some way to visualize the data. Now, again, I don't want you to understand the nitty-gritty details of this function here. It's a very generic function that draws lines in a nice chart. However, I want you to understand the basic structure of this function. So I just want to walk you through real quick through the arguments here that this function has defined. So the first argument is the data that you're going to pass in. And this is going to be an array, and we'll talk in a second about what an array is, but this is all your data points that you want to be plotted as lines. X label and Y label are simply strings for the labels that you want for the x-axis. If you want a legend in your figure, then you have to provide the corresponding strings here, and you have to provide them as an array as well. And again, we'll be talking in a second about what an array is. And then these are two other parameters that we're not going to provide for the moment, but don't worry about that. The function takes care of the fact that you may not provide these two parameters. We'll talk about those later on. We don't need them for the example here. Okay, so what is an array? We'll talk in more detail about array in the next video because it's a really, really important construct. But very briefly, an array, which you can initialize as follows: var data equals, and now here, these types of brackets. So this initializes an empty array. And an array is simply a set of data points, if you will. So a variable, you can think of a variable as containing one data point. So this variable here contains a numerical data point 0.5. This variable here contains a numerical data point 1,000, and so on. In data, you can store many data points. So that's the concept of an array. It's a data structure that allows you to store many values, not just one. And again, don't worry about this. We'll be talking in great detail about arrays in the next video. So what we're going to do here, right? Here we calculate P for every generation. We do this random sampling, and then we get a potentially new value for P. And previously we just plotted P. We just printed P into the console. Now we want to plot it. What I'm going to do is I'm simply going to push this P value into the array. So there's this really handy method that comes with arrays. It's called push. And so you can just push a new data point into the array like this. So we initialize the array here. It's empty. And down here, whenever we call this next generation, this P, this new value P, will be pushed into the data array. And so this is great. So once this loop has finished executing, next generation has been called 1,000 times. We should have an array with 1,000 elements. And now it's high time that we plot this data. So we're going to call this function draw line chart. Okay, draw line chart. And now we need to pass in the correct parameters. And the correct parameters for this case are simply the data as the first parameter. And then we saw that the second and the third argument of the function were the labels. So the first label is going to be generation, because that's what I want to be plotted at the x-axis. And then on the y-axis, I simply want to say P. And then I want to have a legend, just showing what the population size is and how many generations we're running this simulation. So I'll have to pass in an array here for these values of the legend. And each element in the legend will have a title and a value. And these have just to be passed in as the elements of this array. So I want to say population size, colon. So this is a string. And then, so comma, n. So this will show population size, and I'm actually going to use a capital P here. And then just below it will show the value of n. So that's the first element. And then the second should be generations, colon, and then comma, the value of generations, which is in the variable generations. Again, if this doesn't make a whole lot of sense, don't worry. This just sets up a little legend here with two legend items. One has the title population size and then shows the population size. One has the title generations and shows the generations. The important point here really to understand that is we're now passing all this data that we accumulated here into this plotting function, and the plotting function should now nicely plot the data. So let's save this and let's go over to our Drift HTML. We can close the console here. Okay, let's reload this, and it works. Beautiful. And here you see a simulation of P starting at 0.5 and very quickly inching its way upward. It doesn't quite go to fixation, but that's all right. Actually, you know what? Let's go back real quick into your code and reduce the population size to 500, because because that'll give us a little more dramatic results. So let's reload this. So this works. So first of all, indeed, the dynamics are a little bit more dramatic. Here, the population loses the A1 allele at around generation 550 or so. The plotting code works as well, because you can see here that the population size legend here has been automatically updated based on our variable. So if you reload this a couple of times, you'll see very different dynamics. So here, the A1 allele actually goes to fixation. Here it almost goes extinct, but then makes a comeback, almost goes to fixation, but then starts drifting around here again. Here it looks like it's going to extinction. Here it's definitely gone to fixation, and so on. So you can reload this as many, however many times you want to. And it's pretty amazing also if you think about it. I mean, look at this. I'm going to reload, boom, reload, boom, reload, boom. Like, it doesn't even seem to calculate. It's so blazingly fast. And this is really great. I mean, JavaScript in the browser is just stunningly fast. So this is our visualization of genetic drift. And in future videos, we'll take a deeper look at the dynamics here. But in the next video, what I want to do first is dig a little deeper into the concept and the construct of an array, because I mentioned this a few times and we'll make heavy use of it down the line. And so I want to talk a little bit more about this. But if you got this to work, congratulations. Your first visualization in the browser using D3. That's fantastic. I'll see you in the next video.